In this presentation, we have to derive Cauchy Riemann equation. The necessary condition for a function f of z to be analytic in a region R is described by the Cauchy Riemann equations dou u by dou x equal to dou u by dou y and dou u by dou y equal to minus dou u by dou x, provided dou u by dou x, dou u by dou y, dou v by dou x and dou v by dou y exist. Simply we can say the given function f of z is analytic in a particular region. It should possess its derivatives in that region R. Now we have to derive the CR equations. If a function f of z is analytic in a region R, then f dash of z equal to f of z plus delta z minus f of z whole divided by delta z should exist. This is a necessary condition for a function f of z to be analytic. We know that z equal to x plus iy. Then f of z equal to u of x comma y plus I into v of x comma y. Z equal to x plus iy is one function. W equal to u plus iv is another function. If you correlate z and w, then f of z is equal to u of x comma y plus I into v of x comma y. From this, delta z equal to delta x plus I into delta y. Now, f dash of z becomes u of x plus delta x comma y plus delta y plus I into v of x plus delta x comma y plus delta y minus u of x comma y plus I into v of x comma y divided by delta x plus I into delta y. See here, f of z plus delta z. We know that z equal to x plus iy. Delta z is delta x plus I into delta y. Delta x is the increment in the value of x. Delta y is the increment in the value of y. Instead of this f of z plus delta z, we can write u of x plus delta x, comma y plus delta y plus I into v of x plus delta x, comma y plus delta y minus of f of z. F of z is u of x comma y plus I into v of x comma y whole divided by delta z. Delta z is equal to delta x plus I into delta y. With the help of this equation, we have to get two conditions for f dash of z. If delta z is fully real, if delta z is fully real, see this diagram, z equal to x, delta z equal to delta x. This is P, this is new point Q. The change in the value of z is taken along the x-axis alone. Delta z equal to delta x. Here the value of delta y equal to 0. Now, the value of f dash of z becomes limit. Here instead of delta z, we have to put delta x. Delta x tends to 0. U of x plus delta x comma y plus I into v of x plus delta x comma y minus of u of x comma y plus I into v of x comma y whole divided by this delta x. Here we have to put delta y equal to 0. Here also delta y 0, delta y 0, delta y 0. Now f dash of z equal to u into x plus delta x comma y minus of this term u of x comma y whole divided by delta x. This is a real term plus imaginary part I into v of x plus delta x comma y minus, we have taken out I outside, minus v of x comma y divided by delta x. This is f dash of z, which is equal to, this is our dou u by dou x, dou u by dou x plus I into dou v by dou x. Assume this one as equation A. This is dou u by dou x plus I into, this is dou v by dou x. This is equation A. If delta z is fully real, we can get this equation A. Next we have to consider if delta z is fully imaginary. If delta z is fully imaginary, the change in the value of y is taken along the, change in the value of z is taken along the y axis. Therefore, delta z equal to delta y, delta x equal to 0. In this equation f dash of z, put delta x equal to 0. You can get f dash of z equal to limit delta y tends to 0, u of x comma y plus delta y plus I into v of x comma y plus delta y minus u of x comma y plus I into v of x comma y whole divided by I into delta y, because delta x is 0. This is equal to u into x comma y plus delta y minus u of x comma y whole divided by I into delta y plus v of x comma y plus delta y minus v of x comma y whole divided by delta y. See here, if you combine these two, we can get our imaginary term. But if you consider the imaginary term, I by I cancel out, we can get the real term. V into v of x comma y plus delta y minus of v of x comma y, because I get cancelled, whole divided by delta y. If you take I outside, commonly I into v of x comma y plus delta y minus of v of x comma y whole divided by I get cancelled. So this is real term, this is imaginary term. Now this is modified as 1 by I into dou u by dou y plus dou v by dou y. This is f dash of z. Further we may modify this. F dash of z equal to minus I into dou u by dou y, because multiply this by I, divide and then multiply numerator by I and also the denominator by I. You can get I square equal to minus 1. So minus I into dou u by dou y plus dou v by dou y. This is the value of f dash of z. Assume that this is equation B. Now from the equations A and B, on equating the real and imaginary parts, see this is real part. From equations A and B, on comparing the real part, dou u by dou x equal to dou v by dou y. Then compare the imaginary part, dou u by dou y equal to minus dou v by dou x. Here dou u by dou x is the imaginary part. Here the imaginary part is minus dou u by dou y. Therefore, dou u by dou y equal to minus dou v by dou x. These two equations, on comparing the real part, we can get dou u by dou x equal to dou u by dou y. On comparing the imaginary part, dou v by dou x item is equal to minus dou u by dou y. Therefore, dou u by dou y equal to minus dou v by dou x. So, with the help of these two, you can write dou u by dou x equal to dou v by dou y, dou u by dou y equal to minus dou v by dou x. These two equations are called Cauchy Riemann equations in terms of the Cartesian coordinates x and y.